There's something called the ripple tank, Buddha.
It's a required practical on the GCSE
Right?
Physics A water,
I don't know if
which means when it spins,
if that would make sense to you all now, because this is something that you will be learning in A levels if you're doing the what do we tell? If you all were to do physics for A levels, then inshallah, mostly you will be learning about this. But anyways, I just want to show this also for you all. Okay, can you see this screen, Puta? This is what we call as a ripple tank, right? What is being done here is, Puta, you have a tank, a thin layer of water. Balagana Puta Hondata, you have a layer of water in this tank, right? And then there is some movement that is going to take place, a disturbance to create a wave in water. පල්ලෙහා මොකද පුතා තියෙන්නේ? පල්ලෙහා මොකුත් නෙමෙයි. It's a white screen. Right? මෙතන දැන් බලන්න papers වගේ දාලා තියෙන්නේ. Right? It's just a white screen where you will be observing the what? What do you think? You will be observing the shadow of the ripples that is being formed. Right? Because there is a denser area and the rare area, right? Where when the ripples are taking place, isn't it, Puta? Right? When the water is being disturbed, it's going to move in a certain way, no? So what are we going to do? We are going to observe the shadow of it underneath. Okay? Right. So this is how it works.
AQA and the GCSE Trilogy Combined Science Physics component for AQA. It's the ripple tank. And as you can see how this works, we have a tank of shallow water. We have a bar of wood. Attached to it, we have a motor which has got a weight on it, which means when it spins, it hasn't got a correct center of balance. So basically, it creates a vibration, and that vibration travels to the wood and then causes the water to vibrate. We have a light here, and the light projects down, which creates areas of light and areas of shadow. And the areas of light are the tops of the waves, the peaks of the waves, and the areas of dark are the troughs of the waves.
Okay, now did you understand the term that he used, Buddha? The crest and the trough. The place of light is the crest, and the darker area is the trough. So it's actually mehema, Buddha. Trough, crest, trough, crest, trough, crest. So this is the wave movement, right? And you can see the formation, right, of how the troughs and the crests have occurred in this wave, in this ripple tank. Does this make sense, Buddha? There are multiple experiments like this. So the darker area is denoting downward movement of the particles. The lighter area is denoting the crest of the wave. Okay, it doesn't mean that you have to understand this completely to the core, but only thing that you have to understand is, Puta, water ripples. When you talk about water ripples, it is going to be transverse waves, right? Nothing else. Longitudinal example එක මොකද්ද පුතා? ඔළුවේ තියෙන්න ඕනේ sound. Do you all get these two properly? And the both transverse and longitudinal, both of these require a medium to travel, so they are called as mechanical waves. මේ ටික තේරුණාද?
Yeah, miss.
Okay, right. If this is what you all need to know. You all don't need to know about the ripple tank mechanism and all. I just want to show you all some extra information in case if you all can understand it, then it's much better, right? Okay. Any questions of what we learned till now, Puta?
Miss,
No questions?
yes, I
Yes or
have a
no?
doubt.
Yes, Shafat, go ahead.
Yes, the thing with the longitudinal is that the waves go up and down, and the direction also goes up and down. Is that it?
Longitudinal Puta, they are not going to go up and down. They are going to go from the side. If you're here and if you're going to cause a disturbance to the right, the particles are going to go to the right side, to this side. Okay, right? So they are not going to move up and down and get transmitted. No, they're just going to get pushed towards the direction of the energy. Now, I'll show you this example because you asked this question. If you go all the way down in your book, Puta, look at this. When you talk about sound, here see, Puta. Now, isn't this the exact thing that you saw in the slinky, in the longitudinal wave? You will see a compression that is taking place. No? Now, from here, air molecules, look at this. From here, let's tell a vibration is taking place. Let's tell from here, a person start to shout, like that. Okay? So, what's going to happen? The air molecules through here now at this place are going to have that energy and they are going to get compressed there, and then they are going to pass that energy down to the other molecules, and that they are going to get compressed here. So as that way, can you see they are going to get passed to the direction of the wave movement compression areas. Can you see? So this is exactly what you saw in the longitudinal wave slinky, right? You saw that area of compressions. Does this make sense?
Yeah, miss.
Yeah. So you won't see this kind of a movement in the water ripples. Water ripples පුතා ඒගොල්ලෝ මෙහෙම යන්නේ. Up and down. But sound, it goes in the movement of in the direction of the wave itself. Does this make sense, Puta, to all of you
Yeah,
all?
miss.
Okay, Shafat got it. Shafka, Muaz, Raida.
Yeah, miss.
All right, okay. And we'll come to where we were. Right. Then Putat will get a little bit technical. Okay, we are going to learn some terms now, further terms. Physical quantities associated with wave motion. In this lesson, we will only consider waves of a very simple form known as the sinusoidal waves. Right? අර මේ form එක තියෙන wave එක ගැන විතරයි we are going to learn. Right? This typical form. Okay, what are the terms, Puta? Now balanna හොඳට බලා ගන්න ඕනේ, right? These terms they can ask in the exam. So we are going to learn these. Amplitude. Amplitude is the maximum distance, right, from the source to where the particles can move. Amplitude, right? And then I told you crest to crest or a trough to trough, the distance is what we call the wavelength. Now imagine a wave like this, Puta. මම මේකට අදාළව තව graph එකක් මෙතන අඳින්නම්. Right? If I'm going to draw this like this, Puta, what's going to happen? I'm going to make the waves very packed together. What's going to happen now? What is going to happen to the wavelength, Puta, if I compress them like this? Trough to trough, the distance is now shorter. Now, this kind of a wave, what can you tell about its wavelength? High or low? Compare it with this graph. This variation. Crest to crest is this much. Or make a බලන්න එපා. මම තව එකක් අඳින්නම් මෙතන. I'll draw another one. I'll draw another graph, okay? In this place, like this. Oh my. Now, I'm going to take the distance between a trough to trough, right? Okay. Let's make it a little bit shorter so that I can have two crests and two troughs. Balana puta then. What can you tell about the difference, puta? The wavelength is, which one has the higher wavelength? A or B?
B.
A,
Beam.
right? A is going to have the higher wavelength. And B is having a shorter wavelength. Now let me explain you this also, puta. When you have shorter wavelength, the frequency is going to be high. When you have bigger wavelengths, the frequency is going to be low. Where frequency can puta? Oscillation or move vibration per unit time. Right? Now මේ බලන්න පුතා මේ වගේ මෙතන ඉඳලා මේ වගේ තැනකට යද්දී this has vibrated only 1-2 times. But this one would have vibrated 1, 2, 3, 4, 5, 6, 7, 8 times vibrated. So it's very fast. It's moving crazy. So when it is moving like that, the frequency is high. But this is kind of a slow. Wavelength is high, but what has happened to the frequency? Frequency becomes slow. Does this like theory fall into your head, puta? තේරෙනවද මේක මොකද්ද වෙන්නේ කියලා මෙතන? What is the connection between the lambda and the frequency? Does this make sense, puta?
Yeah, miss.
Yeah. Okay. What about Shafka? Muaz?
I understood it.
Okay. Shafat?
Yeah, miss.
Yeah. So what is the ultimate part that you have to understand, Puta? When the wavelength is decreasing, when the wavelength is decreasing, frequency is high. When the wavelength is increasing, frequency is low. Lambda කියලා තමයි පුතා අපි මේකට කියන්නේ. Right? Wavelength is called, this symbol is called as lambda. Right. Okay. So let's go over here. What are the other terms that we have to know here? The trough, the crest, the wavelength, the amplitude. Amplitude එකේ definition එක බලන්න පුතා මොකද්ද දීලා තියෙන්නේ කියලා. The maximum displacement shown by the particle taking place in the wave motion is known as the amplitude. Right? Amplitude කියන්නේ the maximum displacement shown by the particle. Yes, over here. The maximum distance. This is what we call as the amplitude. Now, if you have come across the tsunami wave, puta, right? What do we understand from that? That amplitude is high, right? So that's what causes the destruction when the amplitude is so high, right? Some even told that they were taller than coconut trees, right? Higher the amplitude. So how was this wave created? By the disturbance in the tectonic plates that take place, right? So that was the source of the vibration. And then that causes all the water to be pushed out of the sea to the land. Okay? Right. Okay. Wavelength of a wave, what do we call it, Puta? The distance between one particle to the closest next particle taking part in the wave motion having the same state of motion. That's what we call as the wavelength. So wavelength එක ගන්න පුතා ඔයා මොනවාද කරන්න ඕනේ? Always measure the distance. Underline this word, two consecutive troughs or crests. A trough to trough or crest to crest. You have to measure the distance. Okay? Right. Period කියන්නේ මොකද්ද පුතා? What is the period? Period means how long does it take? The time taken by a particle to complete one oscillation. Particle for a complete oscillation is known as the period of it. Balana puta, the time taken by the wave to transmit a distance equal to the wavelength is also equal to the period. Balana puta metana, the wavelength is from here to here, right? So how long does it take for it to come from this point to this point, right? Okay, so if we go through this part, okay, may definition එකත් අපි ඉවර කරගමු. When we talk about frequency, the number of oscillations carried out by a particle in a unit time. Okay, given with 1 second, in 1 second, how many times is it going to vibrate, right? How many oscillations is it going to carry? Accordingly, you have the equation F equals 1 over T, right? F equals 1 over T. And the other way is also it's true. T equals 1 over F. Isn't it, Puta? Do you all agree with this?
Yeah, miss.
Frequency is equal to the reciprocal of the period. That's why I wrote it like this. The unit used to measure the frequency is known as hertz. Okay. So speed, you have the equation V equals F lambda. Okay, V, speed of the wave is equals to the frequency of it into the wavelength of it. Right? So frequency we measure from hertz and wavelength we measure from meters. Okay. So that is the equation. So till now, did you all understand what we learned, Puta? තේරුණාද මේ ටික? Any questions? Any concerns?
No, miss.
Raida?
No, miss.
Right. Now the next part is electromagnetic waves. Before coming into that, let's look at the first question, Puta. Balamu, try to do the first question, Puta, exercise 4.1.